Here we're talking about a titration of a weak acid with sodium hydroxide. We have 25 mils of ascorbic acid, and we have a sodium hydroxide solution that's 0.5 molar. First, we're asked to figure out how much sodium hydroxide we need to reach the equivalence point. So let's talk about the equivalence point. At that point, the number of moles of sodium hydroxide added are going to be equal to the number of moles of ascorbic acid. We can start doing the calculation of the number of moles of ascorbic acid by taking the volume of the ascorbic acid solution. It's in milliliters. We're going to convert it to liters and then multiply it by the molarity to give us 8.75 times 10 to the minus 3 moles of ascorbic acid. So the number of moles of sodium hydroxide needs to be equal to that. And we know the molarity of the sodium hydroxide, so then we know that we need a certain number of liters of sodium hydroxide, and I've converted that into milliliters. So at our equivalence point, we have reacted our ascorbic acid with sodium hydroxide, and we had 8.75 times 10 to the minus 3 moles of acid and 8.75 times 10 to the minus 3 moles of base. They react completely. Both of them are used up, and that gives us 8.75 times 10 to the minus 3 moles of sodium ascorbate. But the volume matters here because we need to know the volume because we need the molarity so that we can figure out what the pH is going to be. So we're assuming our volumes are additive. The 25 mils of ascorbic acid solution and the 17.5 mils of sodium hydroxide gives us a total volume of 42.5 milliliters. So we can find the molarity of the sodium ascorbate at the end of the solution by dividing the number of moles of sodium ascorbate by the total volume to get the molarity of 0.206 molar. Now we have the information that we need so that we can determine the pH of the solution at the equivalence point. We're going to write the chemical equation for sodium ascorbate reacting with water. It's ionization reaction, which occurs to give us hydroxide plus ascorbic acid. Sodium is also formed, and I have omitted that from the product side of the reaction. So we have our molarity of sodium ascorbate, and it's going to react to form some ascorbic acid and hydroxide. And we need the Kb of the sodium ascorbate. We can find that by using the Ka of ascorbic acid. Remember, Ka times Kb equals Kw. So we have our equilibrium expression, x squared over 0.206 minus x equals 1.25 times 10 to the minus 10. We're going to assume that the minus x in the denominator is small. That's a good bet when the Kb is such a small number, 10 to the minus 10. So I rearrange my equation and solve for x, and that gives us 5 times 10 to the minus 6. That is the concentration of HA. It's also the concentration of hydroxide. So we can easily find the pOH by taking the negative log of x, and then by subtraction we can get the pH for this solution, which is 8.71.